Hello and welcome back to Mr. Powers Teaches Algebra. We are finally on the last example here for rational expressions, at least the last one I plan on doing. There may be more. And so let's jump right into it. Once again, we got our rules for asymptotes. Here they are. Bam and bam. Pause the video if you like, take a look at it, and always have those ready to go. If you're not having all those memorized, you don't know how to figure them out, then make sure you always go back and you have those. In fact, it might be good to have those in flashcards. Or you can do what I do and try to make sense of it so you have less to remember. Okay, so horizontal asymptotes. I always want to jump into those first. So my asymptotes. Let's go horizontal asymptotes. Horizontal asymptote. There, good enough. What is my horizontal asymptote going to be? Well, the rule is if the degree and the numerator and denominator are the same, take the ratio of their leading coefficients. In this case, it's 1x squared over 1x squared. So it's going to be y equals 1 over 1 or y equals 1. There is the horizontal asymptote I am presented with in this example. Great. Now, my vertical asymptotes, this is where the denominator equals 0, right? Although this looks a little sketchy. I think I'm just going to go ahead and find where both numerator and denominator are equal to 0 right now. So I'm just going to do this off to the side. Let's say x squared minus 4 equals 0. That's going to give me x equals plus or minus 2. And so where the numerator, well, let's go ahead. Yeah, let's go ahead and do it. So where the numerator equals 0, those are my zeros for the function. In other words, those are my roots, or we could say those are my x-intercepts, because that's where y equals 0. So I got x-intercepts. I got negative 2, 0. So we say our x-intercepts. We got negative 2, comma 0, and 2, comma 0. Okay, we got those. But remember, we got to make sure we can't have a 0 over 0. That's going to be a weird thing. So that's just, so I'm looking at this, I'm thinking, oh man, I think there's a 0 over 0 coming. I'll get rid of that for now. So let's look at when our denominator equals 0, right? Because that's our vertical asymptotes. So let's go ahead, our vertical asymptotes are where our denominator equals, or our denominator equals 0, yes. Okay, so we got x squared minus 4x equals 0. Okay, well that implies x times x minus 4 equals 0. So my worries were unfounded. I'm going to get two answers here. I'm going to get x equals 0 or x equals 4. And yep. That's right. Okay, so we got our two vertical asymptotes in this case. That's great. We got two x-intercepts. We got a horizontal asymptote. Everything's looking okay. Everything's looking okay. We need y-intercepts. So where's our y-intercepts? And again, just to remind you, if you need a process to follow, I'm jumping around here. I'm finding all these. Here it is. So you can pause the video and take a look at that if you like. But we are just going to go for it here. We're going for it. We're doing it. Y-intercepts, that's where x equals 0. So I need to find f of 0. F of 0 is... oh, well, no y-intercept, because I already know x cannot equal 0. It's a vertical asymptote. So we're going to say that's undefined. I already did the work for that. F of 0 is undefined. I'll be dividing by 0. So that's no good. All right, great. So no y-intercept. So no y-intercept. No problem. Now we're all set. We can start graphing this and maybe test some points. So we got -2, 0, and 2, 0, if I didn't do anything crazy. So let me see here. Get our orange for that. -2, 0, and 2, 0. We got a couple points. We have no y-intercept. We have a horizontal asymptote at y equals 1. So at y equals 1. So there's our horizontal asymptote right here. There we go. Y equals 1. Okay. And our vertical asymptotes, we got a couple of those guys at 0 and 4. Zero, x equals 0, x equals 4. Okay. We'll label those guys x equals 0, x equals 4. Great. And now, whoops, we can go down a little further here. Now we try to plot this guy out, right? Here, I guess we'll plot it in red. Just from this guy, it looks like maybe our graph is going to be kind of going like this over here. And over here, it looks like it's going to be maybe just kind of going like this. Upside down parabola here. Kind of, not really. And then I don't know what's going on over here, but my suspicion is maybe it's going to kind of be symmetric about this x equals 2. Maybe I'll just go like this, but I'm not sure. Maybe it'll be like that. Maybe it won't. So let's take a look and try some values. What value? F of 5 would be too bad to try. Let's try f of 5. What is f of 5? F of 5. Well, that's going to give me 25 minus 4, so that's 21 over 25 minus 20. Well, that's 5, so that's about 4. It's 4 and a fourth, 4.125. So let's see here. Oh, I get a positive value there. So actually, that guy's all wrong. And I get a value, right? What did I say? F of 5 is about 4. So I get something right about here. So it's looking like maybe my graph's doing something like this. Let's see if I can get this. I should put the gloves on and slide across this graphics tablet a lot better. Okay, so it looks like I'm doing something like that. So just double check here. Is this really -2, 0? If I plug in a -2, I get 0 over -2, I get a 0. Here, this wouldn't be 0. +2, yeah. So -2, I get a 0. I guess that's what it looks like. I don't know. Let's go ahead. Oh, or does it go like this? Does it cross? Let's try a couple points over here. Let's try 1 and 3 also. I'm feeling like we should try 1 and 3. X equals 1 and 3, just for fun. So let's try f of 1. That's going to be -3 over, let's see here, 1 minus 4. Oh, is -3. Okay, f of 1 is 1. F of 1 is +1. Oh, f of 1. What? Oh, yeah, horizontal asymptote. We can cross our horizontal asymptote. Okay, so it's like there's a f of 1. All right, what's f of 3? That's right. Let's try f of 3. What does f of 3 do? F of 3. That's going to be 9 minus 4 is 5. 9 minus 12. That's negative 3. 5 over negative 3. That's almost negative. It's negative. It's like around, let's say it's around negative 2. Okay, so that's going to be 3. Not quite negative, or is it more negative? No, it's not quite negative 2. So, okay, so now I'm getting more of this kind of a picture. So I'm going to stop. It's looking kind of like this over here. Kind of like shoom up here. Like that, kind of. It's not a very good. It should be a little smoother there. But that's what we're kind of getting right now. So we can cross that horizontal asymptote. Here's another way we can do it. Let's check our graph with technology. Okay? And see what we're doing. So we got, in this time, x squared minus 4 over x squared minus 4x. X squared minus 4 over x squared minus 4x. Oh, yes, is exactly what we thought. Look at this weird guy. Huh? Look at this. That's definitely what it's doing. Just for fun, we can get those asymptotes. What was it? X equals 0. We had x equals, was it 4? Yep, 0 and 4. And we had y equals 1 for horizontal asymptote. So we got all those asymptotes in there. And we can make it, we can do this too for our asymptotes. We want to go crazy with it. There we go. And we can see our graph here in red. Look at that. So yeah, that's what it's doing. So we got it right. We did pretty good. It is definitely doing that kind of a thing. This is a much better little sketch than mine, but you get the idea. So there's that example. All right. So there's 3 examples, and I think that'll pretty much do it. The moral of these examples is the more points you check, the better, if you want to get a really good idea of what this graph is doing. But you don't have to do that many. Maybe a few in each one. And you kind of see that a lot of times these guys have kind of a symmetry to them, right? There's this weird symmetry here. There's a symmetry here for sure. There's this other kind of symmetry. So we tend to see that kind of thing with them. And you could tell even when I was doing this, I'm like, that just doesn't feel right. So the more you do these, the more you kind of get a feel for them, and we'll be able to sketch these out no problem. So until next time, enjoy doing math.